Assalamu alaikum and welcome. I'm starting a new playlist that is statistical analysis and interpretation for social sciences. This playlist is meant for the beginners who either don't have knowledge of statistical sciences or they have very limited knowledge of statistics. So the first video is focused on the statistical analysis of categorical data. My dear students, colleagues and followers, kindly watch this video up to the end so that you could understand the whole process. So I'll be using this data set that is it has a number of variables. This is a categorical variable for education where 1 stands for educated and 0 for uneducated. Then I have another categorical variable health where 1 stands for healthy and 0 stands for sick. Then there are marks of students in statistical analysis and interpretation, and then there are marks in research subject. Then I have another variable of gender where 1 stands for male and 0 for female. And then I have another quantitative variable that is marks in statistical analysis after training. Finally, I have another categorical variables having 3 categories of programs, and the final variable is that of ones. So I'll be using this this data set for both the analysis of categorical as well as continuous data. So first I would like to start with the with categorical analysis. So I'll be using the same data analysis. So let me start with the very basics. The very basic or the simplest analysis of a categorical variable is one-way classification or frequency distribution of data. So the frequency, we start with the frequency distribution of variable education. So as I told you, education is a binary categorical variable in which there are a number of people. Some of them are educated and some of them are uneducated. So in order to show this is the frequency distribution of the respondents or students by education. So according to this table, out of total of 110, 38% of them are uneducated and 62% of them are educated. Or in terms of frequency, 42 out of 110 are uneducated and 68 out of 110 students are educated, and this is cumulative frequency distribution. Now let me also show you the frequency distribution of the health variable. So to do that, I'll go to descriptive statistics, Dean frequency, and let me take this out back to the, and let me send this variable. Let me scoot health to here and click OK. So this is the frequency distribution of health. So it shows that out of 110, 74 are healthy and 36 are sick people. So it means that 67% of them are healthy and 33% of them are sick. Now after this, I would like to show you how to tabulate or how to create cross tabs or two-way classification of two descriptive variables. So this time I would like to go to cross tabs, and one of the variables I would scoot here to the row and the other one to column, and then I will click on OK. So here is my cross tab of education, so that we can give it a title like classification or distribution of students by health and education. So this is a two-way table, or you can say this is contingency table or a cross tab. So it means that out of total 36 sick people, 22 are uneducated and 14 are educated, and out of 74 healthy people are healthy student, 20 are uneducated and 54 are educated. Now a question arises, can we find association between these two variables? Yes, we can do that, and in order to study association between these two variables, I would like to use a chi-square test. Let me first share with you how can we do chi-square test. So first I would like to show how can we do that. So here is a chi-square test procedure. So the chi-square test is a statistical method which is used to determine if there is a significant association between two categorical variables. Here the two categorical variables are health and education. So there are 5 or 6 steps in chi-square test analysis. Step number 1 is the null hypothesis, and the null hypothesis for the chi-square test is that there is no association between health and education. Then the alternative hypothesis is that there is association between health and education, and that would be true in case we reject the null hypothesis. Then the third step is level of significance, and this is the predetermined value of significance against which we test the null hypothesis. Then we have test statistic, and the test statistics involved here is chi-square test because we want to measure the association between health and education. Then number 5, there is a decision criteria. So the decision criteria is that if the p-value of the chi-square test is less than 0.05, then we reject the null hypothesis and we conclude that there is statistically significant association or relationship between two categorical variables, that is health and education. If the p-value of the chi-square test is greater than 0.05, then we fail to reject the null hypothesis and we conclude that there is no association between health and education. So let me do that with the help of a cross tab. So again, I had already created cross tab, but at that time I didn't run chi-square test. So this time I would like to also include the chi-square test value. So as before, I'll use one categorical variable row wise and one categorical variable column wise, and then I would click on statistic and I'll check chi-square. So this will give me chi-square test value also. So if I click on OK, so now I have this analysis again. I have the same cross tab of health and education, but this time I'm having Pearson chi-square test value which is equal to 11.920, and its asymptotic two-sided statistical significance or p value is 0.001. Since this observed significance value or p value is less than 0.05, so we reject the null hypothesis of no association between the two categorical variables, and we conclude that there is a significant association or relationship between education and health. After that, I would like to make some graphs of these variables. So let me first draw a bar graph of the variable, simple bar graph of the education. So here I will use education, and if I click OK, then it gives me this variable which is under process. It is still processing, and now here is the bar graph of educated and uneducated. So the number of uneducated out of 110 is equal to 45. So this is 45, and this is the number of educated among all. So 68 of them are educated. Similarly, I can also show you the bar graph of the health variable. So I can also do that, and using the same simple analysis, this time I'll take this out and I'll use health variable, and it will give me simple bar chart of the health variable, and here is my simple bar chart of the health variable. So if you analyze the data, then the total number of healthy student is 74, and the number of sick student is 36, and the total number of student is 110. I can also draw pie chart of both of these variables, that is education and health. So let me start with the pie chart of education first, and then I will show you pie chart of so this is the pie chart of education. So there are two slices. This blue one shows the uneducated, and this shows the proportion of educated. So the total number of uneducated is 42, and the total number of educated is 68. Similarly, I can also make a pie chart of health variable. So let me show you how to do that. So I'll go back to pie, and I'll send this back to the data, and this time I'll use the health variable, and if I click OK, now it will give me pie chart of the health variable, and here also the blue slice shows the number of sick people, and that is 36 out of 110, and the green slice shows the number of healthy people, and these are 74. These are 74. So this is the pie chart of categorical variable, which is health. I can also make cluster bar graph and stacked bar graph. So first I would like to use cluster. So I'll click here instead of simple on clustered, and then I will define, and after define I'll send this variable here, and the health variable defined by this cluster, and after that I would like to click on OK. So here I have cluster diagram. So if you look at this, horizontally we measure uneducated and educated, and there are two types of subdivision. So within uneducated 14 are sick, and this green is healthy. So out of uneducated, or among the uneducated, the number of healthy is 54, and the number of sick is 14, and out of educated 22 are sick, and 20 are healthy. So this is cluster. After that I can also make a stack bar diagram of this. So let me click on this and then stack, and within stack I can send education here, and then health defined by stack. So this is the stack bar graph of the number of respondents or number of students. So this represents uneducated, in which 22 are sick. This 22 are sick, this blue, and this out of uneducated, this shows healthy. So 20 are healthy and 22 are unhealthy, and out of educated 54 are healthy and 14 are sick. So this is stack bar of this data set. After that, I would also like to show some other data analysis of this. So let me see. In this, I have already done this. So this is the frequency table that I made for you, and this is the you can see this is the cross tab or contingency table of education as well as health. And then we have this is the bar graph for education. This is the pie chart for education and educated and uneducated. This is the simple bar for health. 36 are sick and 74 are healthy. This is pie chart for health again, and this is the cross tab for education and health, and here is the chi-square test. So then this is the cluster bar chart for health and education, and this is the also the same, but we have education here, and in this cluster chart we have health horizontally, and here we have education horizontally, and vertically we count we have a frequency of these. This is the stack bar that I just explained for you, and this is the chi-square that I also did for you. So the theory of this is that the chi-square statistic is a measure of how far the observed counts are from the expected count, and the formula is that chi-square is equal to summation of observed minus expected, the square of the square difference of observed and expected frequency divided by the sum of expected frequency when the sum is over all possible values of the categorical variable. And I explained that based on the chi-squared test statistic, since the p value is less than 0.05, so we concluded that we reject the null hypothesis, and we found that, or we concluded that there is a strong association between health and education. So I hope this was